dun, dun. The whole Zoom thing is getting a little exhausting, but you know, we're gonna all hang in there and just get through it together. We're gonna take a break today in the middle. So just, you know, you only have to pay attention for like 30 minutes and then we're gonna take an eyeball break. Okay. So I just wanted to say a couple things. If you saw your grades, you may have seen that some of you got docked maybe a point. This point over the course of the semester will not affect your grade at all, really, if you do the math. However, it is intended to signal to you what to do differently next time. So a lot of people didn't really follow the prompt very clearly. So when I give you a prompt that says, use the article to inform your decision, and then the response you turn in has nothing from the article, you're going to get dinged for that. And that's going to continue to happen. So this first one, don't worry about it. It's not actually going to affect your grade, but it will eventually. And then if you finish addressing the prompt and I haven't called you back to the main room yet, you should always have discussion questions because that's part of your assignment for the reflection. And so you can start discussing those. That's there for you as a fallback. And then I wanted to show an example of one that I thought was really good. Sorry, group, whose this is. I didn't ask your permission, but your names aren't on it, so I figured it's okay. So I'm not going to read this to you. I'll post the slides after if you are one of the groups that felt like you didn't quite understand what the expectations were. I just always want that to be really clear. And if you ever feel like you don't understand what the expectations are, stop me, please, because I never want that to be the case. All right. So as you can see, they talk about, in this example, they reference specific definitions from the article. And talk about how it's related to the should we revive or not revive. So if we're using this definition from this one, then to support why we do not think we should revive empathy. But then at the bottom, if we're using this other definition, by that definition, then we should. Right. So that's exactly what the prompt said. Talk about whether or not we should or shouldn't revive empathy. Use the article to inform your discussion. Okay. Same thing here, just another good example. I'm going to not read it, but I'll post the slides if you want to see those. Okay. And so in some of the documents you guys turned in the questions section, there was a part about feeling confused about the different way that mirror neurons were described in the video we watched in class last time versus the way they were described in the long neuroscience research article. And so we're going to go into breakout rooms here for a few minutes and answer what were those differences? And then, so what are mirror neurons? What do they do? And then what was the difference in the way they were described in the video versus in the article? Questions about that? Okay. And also when you're in the breakout rooms, I don't know, just introduce yourselves. Oh, I saw that dog, Ethan. You guys can show each other your dogs, or I don't know, do whatever you need to do to make it happy. Also, I would remind you, for those of you who are on your phones, part of this class is about building empathy, which I know that's hard to do through Zoom, but look at how I'm looking at all of you. You can do it too. And then we'll take a break in the middle. So if you really have a phone problem, you can check your phone during the break. Okay. So what I'm going to do is, pause the recordings were talked about in the video versus how they were talked about in the article.
We talked about how the video showed a big connection between empathy and mirror neurons, but the article was kind of talking about how it's not necessarily a prerequisite for empathy.
Mm-hmm. Yep. Great. Anybody want to add to that? Maybe from the other room, Allison, Damien, Darby, Xavier?
Yeah, we pretty much said the same thing. Just how like the article explored like the different reasons or explanations for mirror neurons, and the video was like, oh no, it's for sure has something to do with empathy.
Yeah. And so great. Jeremy Rifkin is not a neuroscientist. However, Klaus Lamb, who wrote this article, is. And so this is a common thing that we're going to talk about. This is one of the skills, learning objectives of this class, is learning the difference between sort of how to determine what's been popular science and what people are just saying. You know, so you find some exciting discovery about monkeys seeing a human open a nut, and then they decide that that's applicable to humans and has all of these implications for empathy, when in reality, it might just be a motor response. And like one of the examples they give in the paper is, say you're reading a book. You're not seeing anybody do anything, but you can still have a strong empathic response to a character in a book, right? And that doesn't involve mirror neurons at all, right? And they've been mostly tested in primates also, non-human primates. We're primates too. Okay, great. So I just want to make sure that was clear, because that was one of the things that a few different groups brought up in their questions I have, I'm confused about, etc. And so always be, you know, reminder to be critical of the things even that I'm showing you, right? So I showed that video because I think the story arc is nice about the empathic civilization. However, some of the things he says specifically about mirror neurons maybe aren't quite right. And whenever I do show you something where I think it's not quite right, I'll try to tell you that. Okay. And so thinking about the difference between feeling for and feeling as, we'll touch on that again later. But feeling for someone is compassion or empathic concern, which is different from empathy, which, or emotional empathy, which is just, I feel what you're feeling. So we'll talk about another one of the learning objectives of the class is developing practices that build, I'm using empathy as a blanket term here, but when I say build empathy, what I really mean is build compassion or build wise compassion, which is an aspect of empathy. And so one of these is what in the Buddhist tradition is known as metta meditation or loving kindness meditation. And so to prove to you that this is valuable, okay, and I know you guys are going to want to check out because I'm going to talk for approximately 10 minutes straight. Don't do it because I'm modeling the behavior that I'm going to ask you to do in the reflection for this week. So I'm going to model it a couple times over, and then I'm going to ask you guys to do it for the reflection. So don't check out, please. Okay. So here's one article talking about compassion training. So there's lots of science, you know, probably at this point, I haven't looked it up recently, but, you know, hundreds of articles on the neurobiological impacts of compassion training or loving kindness meditation. And so this is looking at neuroplasticity and changes in the brain after compassion training. And so I'll walk you through what they did in the compassion training. So they had a group in the study. One group did a compassion training, which was a 1-day course of loving kindness meditation for about 6 hours a day during that 1-day course that was led by a teacher with more than 10 years of experience. So this was their bar for what counts as the compassion training. And again, this is for fostering benevolent and friendly attitudes towards oneself, other persons you don't get along with. It's based on the metta meditation from of Buddhist origin. Okay. And so then here, they're going to show them some videos. So this is a commonly used technique in psychology and neuroscience to look at empathic response. So where it says LE, that means low emotion. Where it says HE, that means high emotion. And so they're looking at these video sets and then asking them, so positive affect. Affect is a word psychologists and neuroscientists use to mean mood. Okay, so affect is your mood. So if we're looking at positive affect and negative affect, so A is positive affect, B is negative affect, in the low emotion versus high emotion videos, you can see this is pre-training. So this is before anybody had any training. When you see the low emotion videos, you're pretty positive affect, meaning good mood. And high emotion videos, so these are kind of jarring, upsetting things to have to watch. you see an increase in negative affect. So this is basically just showing that the videos they're having people watch are working the way they're intended to work. And this is a standard procedure that's used often. And this is also pre-training. So again, you watch the higher emotional valence videos, HE, the more upsetting videos, you see more empathy response. And again, this is self-report questionnaires. So in this case, they're measuring empathy by people's responses to a survey. Like, do you feel worried about the person in the video? Okay. And then here, we're looking at after the training. So changes in affect after the training. So if you had the compassion training, that's the red line. And if you had the, if I move this, maybe you can see. Memory, so the control was a memory training. So that's the blue lines. So if we look at, let's say on the left here, positive emotion ratings, you can see that after the training, people who had the compassion training, their positive emotions go up. And their empathy rating also goes up in the low valence, low emotional impact videos. So if you had the compassion training, you have more empathy in the low condition. Whereas there's not much change in the videos that are high emotional valence, that are upsetting. And so basically what they're showing in figure C is that the compassion training, but not the memory training video, increased empathy. And in the high valence situation, you wouldn't really want to increase empathy anyway, probably. Okay. So that's study one. Notice the authors here, okay? Last author is always the main person who runs the lab, teaching you a little bit of how to look at science papers here. So this one's from Social and Cognitive Affective Neuroscience, 2014, Tanya Singer. Okay, so that's the main person running this laboratory who's doing this experiment. It was the same author on the last study, so Singer. Okay, and now we're looking at differential patterns of functional brain plasticity, plasticity meaning that your brain changes after compassion and empathy training. Okay, so in this one, they did an empathy training, then a compassion training, or in the control, they just did 2 different memory trainings. And they did the same type, I'm not going to explain it again, but they did the same type of video task, right? So low emotional valence, meaning how charged it is, and high emotion videos. And that's called socio-affective video task, SOVT is how that's abbreviated. Like I said, common procedure. And so if we look at the data here, you can see that in reports of empathy, that goes up with the empathy training, and then they did a compassion training where it stays about the same. If you look at positive affect, that also goes up mostly with the compassion training, right? So positive affect meaning you're in a good mood. Positive affect is science talk for positive mood. And then negative affect both goes down with the compassion training. And so you can look at the green lines are the memory training for control. And so I know this might be maybe not the most exciting thing, but what I'm trying to give you this skill is being able to look at primary literature for yourself and look at data and interpret it and say, oh, okay, I understand what happened here. And if you read the methods, I'm not going to spend the time to do that, but if you read the methods of the papers, they talk about what's on each axis, right? So what's the questionnaire that they used for self-reported empathy? What's the questionnaire they used for positive affect? And you can look those things up if you're interested in them, but this group is very trustworthy. Tanya Singer is very famous. Yes, Riley.
I think if I'm reading this correctly, so they did an empathy training first. Well, first they showed a video, then they did empathy training, then they showed another video, then they did compassion training on the same group of people.
Yes.
I think that's kind of just interesting that, like, even just serializing that instead of having an isolated group showing it or being shown an empathy video and an isolated group being shown a compassion video, like might have
It's
different
those were the
results.
trainings, not the videos.
Or yeah, a training. But yeah,
Yeah.
I think it might have different results if they isolated those, potentially. I don't know.
Yeah. I think, yes, I think it probably would. And this one's from 2014 and the one before was from 2013. It's the same group. So they're sort of building on their previous study where they did the compassion training in the one we just saw. Okay, and then this next slide is kind of scary, but don't panic. You don't really need to understand. Okay, here's the thing of this class. I'm trying to teach you some methodologies. You don't need to memorize brain regions, because if you want to know, it's not a neuroscience class, it's not a brain science class. You want to know what a brain region is, you can just look it up, right? You don't need to memorize those. But what I do want you to be able to do is to look at a graph like this and not feel totally, look at an image like this from a primary paper and not feel totally freaked out, not feel like, oh, I can't do this, I can't understand this, because you can. And so here they're looking at functional neural changes. So this is an fMRI scan, which we'll talk about a little later, showing neural changes related to empathy in blue and compassion training in red. So where you see blue is a change from the empathy training, red is a change from the compassion training, and that's in comparison to the memory control group. So where you see the blue dot where it says delta, meaning change, that little triangle, change in empathy over, right, like greater than the memory group. And then red is the change in compassion compared to the memory group. And then don't worry about this little green or this little gray part overlaps with empathy meta-analysis. That's just where they're comparing it to a different study. Okay, and then if we look at the bar charts below it, again, you can just, all you really need to take away from this, and you can look up these brain regions if you wanted to, but that these trainings had a concrete measurable effect on changes in the brain, right? So if we look at the affect group meaning they had the empathy training and the compassion training compared to the memory group, we see changes in certain brain regions. Okay, and if you want to know, like I said, if you want to know what they are, you can look it up, but I'm not going to make you memorize that. I just want you to be able to look at a table like this and say, okay, I'm not too intimidated to try to take this on. And then the values represent that on the bar, on the x-axis, the values represent the change in what they call voxels. That's a good word to know if you're reading these papers. A voxel is just where they're getting the signal from. It's just the little region. Kind of, you can think of it like a pixel, but in an fMRI or an EEG. Okay, and now a punchline. So I was saying, look at the author, Tanya Singer. Tanya Singer, this is from Science Magazine 2 years ago. I guess 3 now, it's 2021. But anyway, she is the world's top empathy researcher and has been for years. But her colleagues, 8 to 10 of them all came forward, people who worked under her and with her, and said she bullied and intimidated and is generally kind of a cruel person. So this brings me to the point that just thinking about empathy, studying empathy, understanding it scientifically is not enough. We must also practice. And so anyway, you can look this article up and read it if you want. Okay. And okay, we're going to keep going. This is the last one. And so this is by Richie Davidson. If you look at the last author here. So Richard Davidson is one of the foremost mindfulness researchers. So studies different types of meditation and their neurological impacts. And so looking here at compassion training, altering altruism. Are you guys still with me? I'm going to scroll through the little windows here and see. Yay, faces. Thank you so much. I appreciate you. Okay. So here they're looking at altruistic behavior and compassion training. So if we do a short compassion training, does that have changes in our actual behavior? Right? So we can say, okay, it has changes in our mood and how people report our mood. We can see changes in brain regions from these other studies we just saw. And so now this group is looking at, sure, changes in mood, changes in brain regions, but does it change our behavior? And so I just put up a picture of a dog in case you guys were getting bored because I thought it's cute. And now while you look at this dog, I'll explain to you that in the compassion group, they were doing this 30 minutes a day for 2 weeks. And so there were two different groups. One was compassion, in which they were basically doing loving kindness meditation. So cultivating feelings of compassion and concern for a loved one, yourself, a stranger, and somebody who makes you upset. So that's the general practice with loving kindness meditation. So that's what they were doing in the compassion group. And then the control group, which they call REP, standing for reinterpreting, they were given 30 minutes a day for 2 weeks practice of reinterpreting stressful events that have happened to them in the past, right? So it's a control where you're thinking about past events and trying to decrease negative affect or negative feelings about those past events. Okay, so that's the compassion. Those are the two groups, compassion and the control group. And then they did what is called this is another standard sort of test used in the field where they have a dictator and it's a game where there's a dictator and a victim. The dictator has some amount of money and they give some to the victim. And then the participant, so the participants in this case are the people who've done the trainings. Participants are the people who've done either the compassion training or the control training. And so they can pay some amount of their own money to redistribute. Say, dictator, no, you can't just only give the victim $1. You have to make it more fair. This isn't right, what you're doing. And basically what they see, and this is used because people who have high trait empathy tend to endorse greater levels of redistribution of the money. So this figure that I'm not showing here, it's in their supplementary figures, but basically showing that this does work as a test of empathy because people who have high trait empathy tend to be more willing to spend more of their own money to redistribute funds and make this fair, redistributing funds to the victim. And so what we see in the figure at the bottom is basically that people who had the compassion training after the 2 weeks of compassion training did way more redistribution of funds than people in the control group. And one more kind of moderately intimidating figure. I said it would be 10 minutes and it's been 12. I'm sorry. I am keeping track of the time. Okay, so this is very intimidating looking, perhaps. But again, all you really need to understand from this, you don't really need to understand these brain regions necessarily, but that in an fMRI, they do see changes induced from the compassion training compared to the control group, and that those changes correlate with whether or not people redistributed the funds. So redistribution rank is referring to the game we just saw, where you're redistributing funds from the dictator to the victim. And so the more you redistributed, the more these changes, these brain changes were strongly correlated with the people who redistributed funds. So what they're showing is like, yes, there's a change in the brain region that actually is related to a change in behavior. Okay, I think we're done. And this is Richie Davidson, real sweet guy. You can't find anything nasty about him on the internet anywhere. He runs the Center for Healthy Minds at the University of Madison, Wisconsin, and publishes like bananas. I don't know how he's so happy. When you look at his productive output of papers, it's and you're all still here. Yay. Welcome back. Okay. Any questions about that? I know it's kind of a lot, and I'm recording this. So if you need to watch it again later, I'll post the slides, I'll post the video. Yes, he does do his meditation every day. If you listen to him in podcasts, and you can tell his voice is just so zen. All right, let's take a break. 5 minutes? Does that sound good? Okay. So now that I've done all of this explaining, showing you peer-reviewed scientific articles about the fact that loving kindness meditation changes your mood to be more positive, changes your brain, actual structures in the brain grow and changes your behavior, the way you show up in the world. Hopefully now I've convinced you that this is worth your time. And that we not only have to learn about it and think about it academically, but we also have to practice. And so now we will do exactly that. I'm going to do my best. I'm relatively new in the guiding of the meditations, but I will do my best to guide for you. And this will take about 10 minutes. So just get comfortable. If you don't want your video on during this part, I know I always ask for videos on, but sometimes that can be a little uncomfortable when you're trying to meditate. You're not trying, you are meditating. You're already doing it correctly. So permission to turn your video off if that feels more comfortable. And so the idea behind loving kindness meditation is cultivating feelings of compassion and concern and well-being for ourselves and others. And so start by just getting comfortable, whatever that means for you, in your chair. If you have your phone out, please put it on airplane mode for the next 10 minutes. You shouldn't have it out during class anyway, but if you do, go ahead and take a moment to click that little airplane mode button. And then begin relaxing the body, taking a few deep breaths in and out. Really becoming aware of where your body meets your chair or whatever you're resting on. Feeling that support. A few more deep breaths. And out. Okay. Now I invite you to bring to mind someone or some creature that it is very easy for you to love, very easy for you to feel compassion. Could be a dear friend, family member, dog or cat or pet of any kind. And really picture them in your mind's eye. Maybe they're walking toward you or running toward you. Really feel that warmth in your heart that you feel when you think of this person. How much you love and care and want all good things for them. And we might whisper, we might say something to them. Perhaps a mantra if it feels good. May you be safe. May you be healthy. May you know you are loved. May you be free from suffering. May you be safe. May you be healthy. May you know you are loved. May you be free from suffering. Still really cultivating those warm, fuzzy feelings for this person or being who it's so easy to love. And now, bring to mind just an acquaintance. Maybe somebody in this class who was in your group. You know them, but not really. Maybe a coworker. Just anybody, any kind of neutral person in your life. Picture them keeping those same feelings of warmth and compassion. Send them that same compassion. May you be safe. May you be healthy. May you know you are loved. May you be free from suffering. May you be safe. May you be healthy. May you know you are loved. May you be free from suffering. Sweet acquaintance person. Okay. And now, if you've noticed your mind starting to wander, that's okay. Minds are good at that. Just gently bring it back. Find it helpful to focus on my heart or the breath. Every time it wanders, just bring it back. And now bring to mind yourself, your sweet little self. These same feelings of love that we were feeling for that dear friend or dog, or we turn that around to ourselves. May I be happy. May I be safe. May I know I am loved. May I be free from suffering. May I be safe. May I be healthy. May I know I am loved. May I be free from suffering. And if you can, really feel that warmth toward yourself. Try to love yourself the same way you love your dog. Just, aren't you just a good little person? Mhm. And then in our final step, we want to try to expand this feeling as big as we can, blanketing it out to our friends, our acquaintances, maybe people who are difficult for us. That could be family members, people on the other side of the political aisle. Whoever is challenging every being everywhere, as big as you can get it. May you be safe. May you be healthy. May you know you are loved. Yes, even you, difficult person, you know. May you be free from suffering. May you be safe. May you be healthy. May you know you are loved. May you be free from suffering. And we'll close with just 3 deep breaths. Inhale and exhale. One more. Inhale and out. And last one. Inhale and exhale. All righty. You're going to bring yourself back into your body. Hopefully you didn't leave. I don't think I'm that good of a meditation teacher. Honestly, you're probably all still just right here, but welcome back, everybody. All right. Thanks for playing. That was 10 minutes, maybe 11. And so we won't do this every single class for 10 minutes, but we're going to do it quite often. And I hope you do it on your off days too, even if it's just 5 minutes. I can direct you to resources that are, it's hard for me to focus on your faces now. Okay. Hello. There we go. I can direct you to resources if you want to continue to practice. I'll put those on the Canvas page. Or if you're really feeling it, you can just rewatch the recording of me. Okay. So now this is going to be a little bit of a, yeah, Cosmo, you did so good not barking that whole time though. That was really good. You're a good dog. It's right here. Here, let's see if we can just, there you go. Oh, little dog face. Okay. So, coming back to, this is the last little bit of learning, man. You guys feel okay with this? Let's see. Well, why can't I see it? Oh, there we go. And you see the little plants on the screen? Yes? Okay. Fantastic. So there were also questions about these different techniques. Lots of people listed fMRI, EEG. Wow, this feels like an abrupt transition. Maybe we meditate at the end next time. I don't know. Whew. But we're going to do it. We have to carry on. Despite our just massively growing hearts, we must now think about brain waves. It's all the same thing. All right. So you hear people talking about brain waves all the time, delta, theta, beta, alpha, whatever. So this is just a neural oscillation or rhythmic repetitive patterns of neural activity in the nervous system, generally measured in the brain. And so it's electrical pulses from groups of neurons that are communicating with each other. It looks like this. Did I put in the slides about action potentials and they're just out of order? Nope, I didn't. Dang it. Sorry, guys. So an action potential is just when a neuron fires in the brain. That's the extent that you really need to understand for this class, because this isn't neurology, this isn't neuroscience, but generally an action potential is just an electrical pulse when one neuron signals to another neuron. Okay, that's an action potential. So all these little dots that you see on the graph are action potentials, and that's happening with a certain frequency that neurons are firing. And so within a population, the frequency of those action potentials firing, of the neurons firing, you get a wave, right? So it's cycles per second. Hertz is cycles per second, but it's really just about the frequency of the action potentials within a given population of neurons, okay? And then if we give that frequency Again, hertz is cycles per second. You see on the left here, different hertz. So this is what they're referring to when you say brainwave. So theta is what people are often in, especially advanced meditators when they're meditating. Beta is what we live in, I think often when we're in class, we're in beta, if you're paying attention, hopefully. So this is alertness, you're concentrating, you're trying to think. And then gamma is insight, peak focus, expanded consciousness. There are certain monks who have over 10,000 hours of meditation experience who just kind of live in gamma. What a way to live. But you also had to spend your entire life meditating to get it. So I don't know. There's some certainly cost benefit analysis. Please throw in the chat if you have questions as I'm talking, please. Anyway, oh, there's that sound. Okay, so all of this is just trying to explain brain waves so that we can get to EEG, which was the question that people asked. What's the difference between EEG and fMRI? So this is what an EEG looks like. This is measuring electro, right? So it's measuring electricity, electroencephalography. Encephalo is head, encephalo. So electroencephalography, measuring electricity in the head. And so this just, you put electrodes on the scalp. And so they're just measuring the frequency of action potentials, which is that electrical signaling between neurons. The data looks like this. And so when many neurons interact in this, when many neurons fire at the same time, you get this signal that is strong enough to be detected outside the brain through these electrodes, and you get EEG data or an electric brain graph. So you don't really need to learn how to read these necessarily, just that you're familiar enough that if you see EEG in a paper, you're not going to think, oh, no, I can't read this. I'll never be able to understand. Sure you can. Okay. So again, in clinical context, EEG refers to the recording of the brain's spontaneous electrical activity over a period of time. So if you see an EEG reading, maybe they're giving somebody a test and they're measuring which parts of the brain are being activated at what frequency during that test or while people are meditating or whatever. Okay, so that's EEG. And then here we have fMRI, which is this big machine you see here, functional magnetic resonance imaging. So they put people into these gigantic magnets. The data looks like this. So when you see this type of data, this is generally taken from an fMRI. And I think this is the one I want to show. I might have to do the little, hang on. Sorry, I have to redo it. And then I want to optimize for video clip. Gosh, I love that new feature. Thanks, Zoom. No, I just want to play the video. There we go. It's only 2 minutes. Can you guys hear the sound? Kind of annoying and terrible. It's not.
So if the fingers of the left hand wiggle, right brain lights up. But if it's the fingers of the right hand, left brain activity. And if we bring out the duster, a different area is active. Everyone loves the duster. The clarity of the images we are seeing is down to us using one of the strongest MRI machines in the world. It has a 7 Tesla magnet inside it. That is strong enough to pick up a double-decker bus. But we use it to find out how the brain works. Thanks to the strong magnetic field, the scanner can detect changes in the oxygen levels of the blood in a person's brain. When the fingers of the left hand wiggle, there is an increased electrical activity in the areas of the brain that are used to generate the movement. And to feed the increased demand, more oxygen is delivered by the blood. This can be measured because at an atomic level, a magnetic field makes protons spin. The stronger the magnet, the faster the spin. Crucially, though, the protons in oxygenated blood spin more slowly than those in non-oxygenated blood. And we can detect these differences with our MRI scanner. When the fingers of the other hand wiggle, oxygenated blood flows to the new areas of increased electrical activity. And by deduction, we know these must be the areas being used to produce the new movement. Our experiments show us how our brains respond when we talk, experience pain, watch a film, or listen to music. They allow us to see how our brain changes when we learn new things or recover from damage after, say, a stroke or an accident. Overall, they enhance our understanding of what, I'm sure you'll all agree, is a very important organ, one that we all need to make sure we look after. That duster again.
Kind of like.
Okay. I really like that one. It reminds me of the Magic School Bus. But if that was too complicated for you, so if your scientific background is kind of like, whoosh, what just happened? Basically, they're using a really powerful magnet to measure where oxygenated blood is flowing in the brain. And more oxygenated blood indicates that that brain region must be actively being used right now, because blood flows to the regions that need it. Okay, so that's the really simplest version. And if the video was too much, don't worry about that. Okay. And we're here. Okay. So again, put you in this gigantic machine while you listen to music, watch a film, etc. Like the examples they gave in the video. You'll get data that looks like this, just showing which regions of the brain are being activated when you're doing said activity. If you're really into this, this is a good video. I'm not going to play it because it's kind of longer, but I'll post I'm writing that down. I'll post this on the Canvas resources page because it's pretty interesting. A little more technical detail, but it's well done, of functional magnetic resonance imaging. Okay, so the techniques we have so far: EEG measures electrical impulses in the brain with the little electrode hat that you see. fMRI measures where blood flow is going to show which regions are activated. So when you see brain wave data, right? So they were in theta or they were in alpha, that's generally coming from an EEG. Okay, and then this one is more, the mechanism is unknown, basically, but transcranial magnetic stimulation, this image is from Mayo Clinic. It's a non-invasive procedure in which basically they use a gigantic magnetic coil that makes a magnetic field, or electromagnetic coil that makes a magnetic field that will penetrate down into the brain to stimulate nerve cells in the brain. This is often used as a treatment for depression, is one of the most common applications of this. And we saw it mentioned in the article, so I'm just bringing it up here. But the exact sort of molecular mechanism of why this works, we don't really know. Maybe it's just increasing blood flow. I tried to read around about it, and maybe somebody does know, but I cover a lot of content, and so I don't know, and the internet at first glance does not readily know the exact molecular mechanism of how this one works. All right. Whew.
I've always heard that mentioned in the same vein as kind of like ketamine infusions and stuff, where it's like there's a ton of anecdotal evidence, but the exact mechanism is still unknown, I think.
I don't know. I can neither confirm or deny.
There's a lot of research with ketamine, and it's shown to increase neuroplasticity as well as create new neural pathways. So if you think about like how we're just going down the same old dirt road, it's basically like repaving the road so that you go down different roads, or putting leaves back on a tree in winter.
Mm-hmm. Yeah. I know that same thing is true with psilocybin research. I haven't looked much at the literature on ketamine, but yeah. All right. Well, you guys, I I had another activity, but I don't think we really have enough time to do it actually, because there's only a few minutes left. So we'll just start with it next time. I think that's okay. I know this one was a lot of talking, but hopefully it's useful. We'll kind of mix activities with talking, and please, as I said, I'll post the reflection. Part of the reason I modeled that behavior of finding a paper listing the methods and the findings is that I'm going to ask you to do the same thing in your reflection. Okay. And so a good place to go to do that is, and I'll post this in the reflection too, but, which one of these produces brainwave data? Sorry, I'm just catching up on the chat now. EEG.
Yeah.
Wow, that's so great. I didn't even see that and I answered it. That feels good. Feels really good. Okay. So Richard Davidson, and I'll post the link in the reflection too, but at that website, they have a whole list of publications. And so it's a really easy place to go to find publications where you can feel confident that the quality is going to be good. And I think this is generally a good way to go about finding scientific publications. If you know a particular research group is fairly trustworthy, you can go to their group's page and look at their publications rather than just searching on Google Scholar at random where you're not really sure what you can and can't trust. So just a little pro tip. Anyway, so that'll be part of the reflection. And then next week, we're going to talk about the evolution of pro-social behavior. And for those of you who thought this class was going to be about technology, we're going to get there. We're going to redesign some social systems and try to do that sort of thing too. But we can't really do it if we're just do it effectively if we're just throwing empathy around like a blanket word like the rest of popular science culture, right? We got to know what we're talking about. Okay. So we'll get there. All right. That's it for me. We're 5 minutes early. Thank you for coming. Thank you for having your cameras on. Thank you for listening. I know I talked a long time, but I appreciate you. All right.
Thank you so
Thank
much.
you.
Have a beautiful weekend.
You too.
Thanks,
See you
Amy.
Tuesday.
Thank you.
Bye.